Anyway, I'll start with a brief introduction of who I am for the people who don't know. Then I'll go into the question what a WIG craft actually is. If you see it as an aircraft, what the consequences are. If you see it as a boat, what the consequences are. Then I'll briefly touch the history and current developments of WIG craft, and I'll finish with some remarks on commercialization of this technology. Oh, wrong one. I'm an aeronautical engineer. I graduated from Delft University of Technology in 1995. My thesis subject was the design of a wing and ground effect craft, and that's where my interest in this subject started. About a year later I discovered the internet, and I decided to put some information on wing and ground effect on the internet, and that started as the WIG page, and it still exists, and apparently many people are interested in this subject and visit this site. About a year ago I decided to also start some commercial or business venture in this area, and I started my own company called Surface Effect Technology, abbreviated to SE Technology, and I'm involved in some projects basically aimed at commercializing this technology and making it a well accepted means of transportation. So what is a WIG craft? For those of you who've never seen anything like it, I have two photos here of examples. This one is a German prototype. This one is the Russian Amphistar, which has recently been renamed to Aquaglide. And what you see is they may look a little bit like aircraft, but they fly above the water. So they're not an aircraft, they're not a boat, but there's something in between. Perhaps the best way to describe them is as a hydroplane, like the race boats you see, the offshore race boats, or like these, the hydroplane race boats, they reach speeds like 200 or even more kilometers per hour. Or another way of looking at them is to see it as a hovercraft, because a hovercraft is also flying just above the surface of the water. It's flying on a cushion of air. It's being bounded by an actual rubber skirt. This one is also flying on a cushion of air, which is formed below its wings because it's got very stubby small wings, and in cruise or at maximum speed these boats do not touch the water. Only the water prop touches the water. The rest is clear of the water. It can be as much as 10-20 centimeters. So although this wing and ground effect may appear to be a very new and different technology, it has been around for many years in a different form. So it's not all that revolutionary, it's just a little bit different. I think you could describe it as just an ACV, which means air cushion vehicle, because there is an air cushion under it, and it's the way it is formed is just a little bit different as in a standard hovercraft type air cushion vehicle. If you look at WIG craft as aircraft, so you look at the aerodynamics of the craft, if an airplane is flying out of ground effect, so just in free air like all aircraft do, you have two tip vortices, which I'm sure you all know about this, because there's high pressure air under the wing, low pressure air above the wing, so you get air flowing from under the wing to the top of the wing, and that creates two wingtip vortices. A part of the drag of the aircraft, the resistance of the aircraft, is actually the energy that is being stored in these wingtip vortices. And one of the features of ground effect, or one of the effects of ground effect, is that the way these tip vortices are being produced is somehow bounded by the ground. So this whole air which wants to flow from the bottom to the top is bounded by the ground. So the strength of these vortices will be less. So the energy stored in these vortices will be less, which means that the lift-induced drag will be less, which is only a small, it's not a small, but it's only a portion of the lift, but still it will be less. So that can be considered as an advantage of a WIG craft over an aircraft. sometimes we call this span-dominated ground effect. I think Mr. Kirill Rostisvensky introduced this term, but I'm not sure. Wait a minute. Somehow it doesn't go to the next. Problem. I've got a small computer problem here. How can I stop in French? Who knows what I do here? Yeah, I'll just do it like this because it must work like this. Can I go further? Yeah, this will be all right. I'll do it like this. Yeah. Okay. Another way of looking at ground effect is what's sometimes called as chordwise ground effect. Is that you get increased lift. I illustrate this by a two-dimensional calculation, a small panel method calculation that I made a while ago. Just as an illustration, I took an airfoil, I think it's a NACA 4412 or something, I'm not exactly sure, but it doesn't really matter for this case. And I calculated it without ground effect and in ground effect, both at an angle of incidence of 5 degrees. This one without ground effect, as I said, and this one at a height of 5% of the chord, so it's really, really low. And you'll see the difference in pressure distribution. That's the blue line here. The main difference is on the bottom. Here you'll see just a common pressure distribution, which you'll see in all normal airfoils. And here you see that the pressure on the bottom of the wing is almost stagnation pressure all the way to the back. So that's a big increase in lift. You do sacrifice a little bit on the top, and also the suction peak becomes a little bit higher. So there's some more complications to the whole story, especially since this is just potential flow theory. But the main message is that you get a lot of extra lift on the bottom of the wing, and that is the air cushion that I was just talking about. The wing is closer to the ground, and it creates some sort of an air cushion below it. Here you see the difference in lift coefficient. It's 0.8, and here it's 1.1. The consequences of these two features is that you'll have a higher L over D in ground effect, so the lift divided by the drag will give you a higher number, which means that the craft will be more efficient because the lift is higher and the drag is lower. But a secondary effect, which is perhaps much more important, is that the longitudinal stability may give problems. That can easily be seen in this picture, because here the majority of the lift is created in the front of the wing. Here the majority of the lift is created in the middle of the wing. So when a wing or a wing ground effect craft or an aircraft is climbing from ground effect to out of ground effect, the point where the lift acts, the lift factor acts, is moving forward. So this can give an effect, as you see in this picture. It's not a very clear picture, but it's the best I could find, of the racing boats, the hydroplane racing boats, which meet an occasional wave or a headwind gust or something. They climb out a little bit further out of ground effect, the lift factor goes forward, and they flip backwards quite violently. And that's a major problem of wing ground effect craft. And it has been experienced the first time, I think, in the 1930s. And it has only been solved quite recently, like a few decades ago. If you look at WIG craft as boats, and you compare them to other sorts of ships, especially high-speed ships, you see that the main problem when you want to go faster with a boat is the drag of the water, the resistance of the water. So what you want to do is you want to create minimum contact with the water in order to reduce resistance, so you reduce the required power. The ultimate minimum water contact boat would be a WIG craft, because there's no water contact at all. what you'll see in WIG craft is that the power per unit weight, which I put on the vertical axis here, is very low as compared to other types of transport. Here the red area is where WIG crafts are, current or projected prototypes. Here's the speed. So you see they're generally in an area between 100 and 350, 400 kilometers an hour. This is the cruise, the amount of power required for cruise. So that's a very important thing, but I'll get back to that in the next slide. You see that you need a lot less energy or installed power than an aircraft. You also need less than a hovercraft or a hydrofoil boat, but you need more than a ship. But a ship goes a lot slower. And you can see that there is a gap between the ship and a WIG in the amount of power that is used to cruise. The problem is to go from this low speed area to the higher speed area. So when a WIG craft will take off, initially you need to act like a ship because you're not in the air yet. So you have to overcome the resistance that a ship needs to overcome to get up to speed. And usually that's called hump drag. That's the reason it's called hump drag is because it's a high peak in the drag. And you can see that if you are planning ship before you're into ground effect, you follow the ship curve and you'll end up all the way up here somewhere. So you need a very high power, and then you're in ground effect and you suddenly need very low power. So this is another major complication of ground effect, a technical complication. In the past, some solutions have been found for this problem. First of all, the Russian approach. This is KM, the Caspian Sea Monster, the biggest wing ground effect ever. And this is Olyonok, which is a descendant of the same technology, a little bit smaller, but a little bit more practical in use. And what you can see here is that it's got a lot of engines in the front. And all of these engines, during the start, they will blow under the wing. They've got deflectors on the nozzles to blow under the wing. And what you see here is Olyonok taking off. You see all the spray here being generated by the two jets blowing under the wings. So that's a way of creating an artificial air cushion before the aerodynamics will create the air cushion at full speed. Another way of trying to get out of the water sooner to reduce the resistance in the water is to employ small hydrofoils. They're not very clear to see, but this is the best picture I could find. This craft, the hydro wing, also made in Germany, uses two small hydrofoils. They extend at takeoff, so it can be raised out of the water soon, and then as soon as it's out of the water, then ground effect takes over. It's been applied with limited success. So another very recent way of solving the problem is the hover wing by Mr. Fisher. This is an artificial air cushion is generated under the body of the craft by something very similar to surface effect ship technology or hovercraft technology. A little bit of the airstream behind the propeller is deflected, blown under the hull, and you'll see a gap here, and you'll see skirts here. These are details of the bottom of the hull. So at takeoff, it actually acts as an air cushion vehicle rather than a ship, which is a little bit more efficient. So that makes the power requirement at takeoff somewhat less. Then I want to go into the history of wing ground effect craft. I just have a very broad overview. The more detailed overview you'll find in the proceedings. It really all started around 1960, and the two main contributors were in Russia and in Germany, were called Alexeyev and Lippisch. They both had a very different approach. They didn't know of each other. They didn't know what the other one was doing. Perhaps Alexeyev knew about Lippisch, but Lippisch certainly didn't know about Alexeyev because it was very secret, the Russian program at that time. And they encountered the same problems, but they solved it entirely differently. So you'll see this is the more or less Russian approach. This is the American-German approach, because Lippisch started this whole thing in America. This led to craft like the Volga, Amphistar that are currently, and the Aquaglide that are currently around. This led to craft like the FS-8, the Flight Ship 8, and Hoverwing. Here another one is missing. Anyway, there are over the years different WIG boat concepts have been developed. One is a simple plain ram wing. They call it a ram wing because it's the ram air that is under the wing is creating the cushion. Nothing special about it, just a wing and a tail, that's it. This proved to not really work very well. So that's why the Russians came up with the ekranoplan concept, which is actually very similar to the ram wing, but it's got flaps and it's got the two engines in the front which blow under the wing. Another modification to the ram wing is the tandem wing, which was invented by Mr. Jörg. There's in fact two ram wings in a tandem configuration, which will make it more stable in ground effect. And another variation to the ram wing is actually also a ram wing, but it's got a very special shape, the reverse delta, which will make it a little bit more stable in ground effect. Now that we know a little bit about what sort of WIG craft there are and whether they're aircraft or boats, it's important if people want to operate a WIG craft, what do they need a pilot's license? Do they need a boating license? What are they? Are they a captain? Are they a pilot? So that's why I think about 10 years ago the first initiatives started to talk with IMO about it, and the Russians have proposed we call it 3 different types of ground effect. They call it type A, B and C. Type A is a craft that can only fly in very strong ground effect. It cannot leave ground effect, it must always fly in ground effect. It will act exactly the same as a hovercraft, for example. An example of this type of craft is, for example, a tandem craft or the Aquaglide or the Volga. Another approach is type B. It's exactly the same as type A, is that it can fly in ground effect, but there's one added feature. It has an elevator so it can jump temporarily out of ground effect. It doesn't have enough power to stay out of ground effect, so it cannot fly like an aircraft. It can only jump over an obstacle or something. And then there's a type C, and that's defined as a craft that can fly in ground effect, but also out of ground effect. So in that respect, it's no different from an aircraft or basically a seaplane. And actually, there's a fourth type, which is not mentioned very often. But when you have a WIG craft that is somehow always in contact with the water, for example, the propulsion or a hydrofoil or something that's always in contact with the water, then it's just a high-speed ship, and it falls under the high-speed craft code, which is an IMO. IMO is International Maritime Organization, by the way, which is IMO definition for any, like a catamaran, a trimaran, all the fast ships that are around. Currently, there are a lot of developments taking place all around the world to commercialize ground effect, and I've assembled some pictures here of current things. I've just mentioned the Flight Ship 8, which is a brother or a sister of the Hoverwing, if I may say so. Both developed by Mr. Fisher, and the Flight Ship 8 is due to go into production this year. Hoverwing is only on the drawing board, but the prototype has been successfully tested. This is a photo of the Aquaglide, which is a descendant of the Amphistar, which was developed around 1995 in Russia and been commercialized together with American companies. This is a photo of the TY1, which is a Chinese wing ground effect craft. And it looks very similar to the Russian approach, and it looks a little bit like a scaled up Volga, but it's a little bit, it seems to fly a little bit further out of ground effect, and it doesn't have the air cushion, the skirts underneath. And perhaps two less known examples of wing ground effect are the wing made by Mr. Clifford from Incat, and the C-bus, which only exists on paper, which is a European Union project. Both of these have wings, which create a cushion to make it a little bit more efficient at high speeds, but they also keep water contact at all times. So they have water propulsion. This one is water jets, this one's got a surface drive, and even at full speed they will be in contact with the water, so they will be less efficient as the other craft, but classification and market acceptance may be a little bit easier simply because it appears to be more like a ship. If you look at the commercial side, to look at what are the opportunities for WIG boats. If you look at the past 10, 20 years, then high speed is a trend in shipping. You see that every generation of ships is faster than the generation before. And currently they're pushing the limit where it's still, where the craft is going so fast that you need so much fuel that the fuel costs become very dominant. So they are looking for technologies to improve the efficiency. And I think that WIG boats can close the bridge between the relatively slow and cheap boats and relatively fast and expensive aircraft. Because if you look at the von Karman-Gabrieli diagram, which is something to compare different sorts of transport, I put down the L over D here, which is a measure for the efficiency, and here I put the speed, both on logarithmic scales, and you see that there's an area here where there's no other craft. So all the lines are different craft. This is, for example, a bicycle. This is a horse. The line here, the green line, is a car. This is a train. Here you see the hovercraft and the hydrofoil, and all the light blue ones here are aircraft. And you see that between the marine technology, which is a dark blue lines, and air technology, aviation, which is the light blue, there is a triangle where nothing exists. And that's a speed between, let's say, 100 and 500 kilometers an hour, and an L over D between 10 and 30. This is exactly the gap that WIG craft could fill, especially when they're seen as marine craft and they can operate at relatively low marine operating costs without all the heavily certification like FAA, all the rulings. They can use the marine infrastructure, and another very important feature of wing ground effect is if you have a planning ship or any fast ship and there's a little bit of waves, it gets very uncomfortable for the passengers because there's a lot of vibration from the waves. And a WIG craft, as soon as it left the water, will be a very smooth ride. So eventually the passenger comfort will be high as well. I've here compared different types of transport over water. I put over in brackets because an aircraft cannot be considered to be water transport, but you can transport people over water in different aspects. So if you look at a boat, these are the cruising speeds. Here I put the relative fuel consumption. I didn't put absolute numbers in it because that would make it very complicated. So if you look at the ways how they compare, you see that a WIG boat is on almost all aspects is medium. So you could say that it's an average thing. It's neither fish nor flesh. It's nothing, so it's useless. But in fact, it creates a very interesting niche between expensive and fast and cheap and slow. So that's why I think it can be a very, for operators, a very interesting alternative. If you look at what sort of operators could use wing ground effect craft, of course there's passenger transport. You can think of public transport just going from one harbor to another one port to another one. There are also interest for hotels and tourism. For example, if you have an archipelago somewhere where a lot of hotels are scattered around and there's one big airport in the middle, all the tourists need to be transported from the airport to all of the hotels. And for example, WIG craft could be a very good alternative there. Another thing is oil companies which have people and material need to go to the oil rigs all the time. They can do it by helicopter, very expensive and very fast. They can do it by a boat, which is very slow and very cheap. and now they have an alternative which is just in between. Another very interesting market would be law enforcement, and it could be all sorts of things, from police, customs, coast guard, fishery inspection. All countries that have a lot of water around it will be interested in a craft which is and fast and relatively cheap to operate, and furthermore it can, for example, an aircraft will be able to survey a lot bigger area at the same time. But when an aircraft sees a boat which is fishing illegally at some spot, it can send out a warning message, it can send out a ship to go there, but it can't do anything. Yeah, it can shoot it down, but that's not really an alternative. So a WIG craft can actually, like an aircraft, be very fast and pursue the boat, but it can actually also land and go down to it and enforce its whatever it wants to do. Another thing is a small cargo, especially like perishable goods or fast things that need to go quite fast, or aid services, can also be done with wing and ground effect. Wing and ground effect is not suitable to use everywhere because you have a quite limited wave height, because you need to take off from the water. So the water, the sea state, the weather and the wave height restricts the operation. There are certain areas around the world which would be most suitable for WIG craft, especially relatively small ones who can handle only relatively small waves. And these areas I indicated here, around the Caribbean, here around the Mediterranean, the Baltic, and the Southeast Asia. And here I mentioned some of the other areas which are possible. But if you look at the wave height data of these areas, then you can operate in quite a substantial amount of the year for a relatively large time. Finally, I'd like to make some conclusions. I think over the years the aerodynamic and hydrodynamic problems associated with WIG craft have been solved, like the stability problems and the takeoff problems. If you look at the technology, I think that WIG craft are and should be boats. From an operational point of view, it will make the whole thing a lot cheaper and better, easier to operate. WIG craft have low drag at high speeds, where they compete very well with existing high-speed boats. They fill the gap between ships and aircraft. They've been developed since the 60s, and I think currently they are ready for commercial operation. Finally, I'd like to thank you for your attention, and I'd like to welcome any questions there are. Thank you.
Okay, so it's time for question now. I have a microphone, so raise your hand and I will call me immediately to give this microphone. Please present yourself shortly.
Hi everybody, I'm Corneliu Dima from Bucharest. I'd like to put a couple of questions to you. First of all, you have shown some CP distributions corresponding to different incidence angles. Have you thought of an incidence correction depending on the height to the ground, like for instance in the wind tunnel corrections? So you know, in the wind tunnel they correct incidence just to correct the wall effects, okay? Mm-hmm. Have you thought of some application of this type?
This was only just an illustration of what ground effect does to a wing in a certain, like if you do, I only meant to compare two exactly the same situations, the only difference being the ground. So I didn't correct anything, and it's not at all a scientific experiment or whatever. It's just a
yeah, my question does not concern what you've done. If you have thought of doing an incidence correction just to simulate the ground effect.
An incidence correction
Yeah.
to simulate ground effect. I've never heard of that before.
Well, you know, they do it in the wind tunnel corrections. They correct the incidence to get the wind tunnel effect, okay?
I'm not sure I understand exactly what you mean, but...
Well, if you do wind tunnel tests,
Yes.
okay, the effects of the walls can be corrected by correcting incidence and Reynolds number, okay? You know that. That's in the aerodynamic books. Have you thought of doing some corrections of this type in your case?
You mean in the calculation of this the 2D airfoil?
Yeah. If by correcting the incidence you can get the same effect on the CP distribution.
No, you can't. You can't.
You sure?
Not exactly the same. I haven't tried it, but the ground
It's
effect...
just an idea. It's a question.
Ground effect is different from just applying a higher angle of attack. You don't... Even if you get a higher angle of attack, the lift distribution of a wing will not be... will not give you a CP of 1 all the way on the bottom. It will be very different. So you cannot reproduce the CP distribution around the wing just by changing the angle of incidence.
Maybe somebody in the attendance could answer to this also?
It is an answer to a remark for him. I am Mr. Mazur from France. Good. When you make correction in a wind tunnel, it is because you have a ground effect, and that you want to know the lift in free flight. So it is the same thing.
Now, what I meant to say is, you cannot reproduce the same
No, that's right.
distribution of lift around the wing just by changing the angle of incidence, because the bottom lift distribution will be different. They will not be the same. You cannot get stagnation all the way under the wing just by applying a different...
I think that we are not in the domain of correction now, because we are so close to the wall that it's not possible to replace by a simple changement of incidence. And in fact, it's quite, well, when you see the pressure distribution and you see on the lower side, the CP is very high, and I never saw such CP distribution on only changing the angle of attack.
If you change it to 90 degrees, you may get CP
Okay.
1 all on the bottom.
I think, of course, this question has quite reasonable grounds, but this is what can be done and has been done in the first days, so to say, of taking account of the ground effect in aviation. So when the wing is far enough, it's sort of a lifting line. And so the first theories, like that of Prantl and Wieselsberger, were efficiently taking effect of the induced downwash, which is also made for as wall correction. But here she has been in area of this strong ground effect, where it cannot be done because the wing is too close, as you have said. So, I mean, that's a reasonable question, but not in this case. And the pressure distribution, of course, is quite different.
Well, okay.
Have you forgot of mentioning UAV application for this kind of vehicles? I mean, unmanned air vehicles.
Yeah.
You didn't mention them.
Well, why would unmanned air vehicles be interesting for wing ground effect?
Oh, because they are doing more or less the same thing as you've shown in the applications. You know, inspections and all over.
Oh, as
okay.
an alternative, you mean?
Okay. And the third is, what happens when the sea is not smooth? I mean, big waves and so on.
If the waves are too big, you cannot operate. It depends on the size of the craft, of course. The size of the waves must be seen relative to the size of the craft. So a boat which is 20 meters long can handle bigger waves than a boat which is 10 meters long, because it's all relative. But in practice, when the weather is too bad, you can simply not operate. So it's limited by weather, by sea state, by all that. And if you would encounter very unexpected heavy weathers during a flight, you'd simply have to settle down and wait for it to go away. But that's operational problems which haven't been met so far because they aren't in operation yet. So.
Jean-Marc Gaille from Airbus, but I'm here for a personal reason. My understanding was you said that WIG craft should take off only from the water regarding regulation. But I think that if WIGs try to take off from the ground, you will have no resistance from the water. And is it regulation, or is it for regulation reason why WIG craft should take off only from the water? Or
so far, just historically, all or most WIG craft have been water-based. Some are can go from snow or ice, and some of them are amphibious. But if you have a purely land-based WIG craft, so with wheels and everything, just to take off from an airfield, then you lose a lot of the potential advantages that WIG craft are, because you become very dependent on infrastructure again. You cannot land on the water in any emergency or something. You also have between the runway and the water, you have to have an unobstructed, almost a runway again, to fly over to get to the water. Or if you want to go from Paris to Toulouse, for example, with a ground effect craft, you would need to have some sort of a big, almost a runway, a big concrete highway to fly over. So it becomes a totally different concept then, and actually this has been researched mainly in Japan, because they're thinking of having trains rather than the maglev trains, the magnetic levitation trains. As an alternative to that, they're proposing to make real big concrete, not a tunnel but a half tunnel, and then to have some sort of a train flying in ground effect flying through it as an alternative. And that would be very close to what you're saying. And in that case, you will not need any regulation at all, not ship-based regulation, because it becomes a train then. So I think if you're looking at that, you get a totally different concept of a vehicle, which will have totally different applications. I hope that answered your question.
Yes.
Yes, I'm Richard Rydberg from Sweden, and I would like to ask again this: why don't you start from land-based area? Because when we saw this part, you did some extrapolation from the power needed to get a boat to a very high speed before it lifted. So if you did the same from the car, perhaps one wouldn't need as much power to get into the wing and ground effect area.
That's basically the same question.
Yeah, but I didn't think that you specified that really.
Oh,
I thought that you just mentioned that it was really hard, but to use these runways on the ground. But perhaps one could start on the ground and then fly out over the water and continue from there.
But in that case, you'll have an aircraft, because it'll become an airplane in that case, because you need to go from the runway to the sea, and you need to fly to get there.
Well, one could use a runway in the vicinity of the.
Yeah, but you have to have special infrastructure.
Oh, okay.
So there's always a downside to every.
Okay. Another question about the length. You said that one could handle more sea with a larger aircraft. What is the interesting length? Is it the chord length, or is it the total length of the aircraft?
Generally, it's proportional to the size. I just said length, but it could also be width, or just generally the amount of the sea state that a craft can take is proportional to its size. If you have a craft twice the size, it can handle twice the weight. Because so the flying height is relative to the chord length in many cases. So in that case, if you have a craft that's twice as long, you'll have the same ground effect If you fly twice as high, in that case you can handle twice the size of the wave. The waves, yeah.
Sorry, Mr. van Opstal, I've got a question. You gave us a complete overview about the technologies. Could you please figure out the difference between hovercraft and tandem airfoil flare boats? Because I think tandem airfoil flare boats is a very important part of science. It is classified as type A craft, but technology is quite another.
Yeah, but what I meant to say with similar to hovercraft is the way they operate. Is they have only directional control and speed control. They cannot leave ground effect. So in that respect they are very similar to hovercraft. And from a certification point of view, the authorities will be very, how shall I say that? They will not object very much to a tandem craft because it is very similar to something that already exists. And they may object more to a WIG craft that can fly higher because they say that looks like an aircraft. So that's what I meant to say when I said it's similar to a hovercraft. It's just that in operation it's yeah, not the physics of it, of course.
Technology is very different.
Yes, of course.
Because we have got a double wing system. That is an important fact.
Yeah, but I just meant to say that from an operational point of view, or certificational point of view, it's similar. Technically, it's totally different. But that doesn't matter. The customer doesn't care about the technical stuff inside it. He only sees what it's like and how it operates. So, okay.
Is there any question?
Mario Michalina from Zagreb. I would like that what you told us about using this technology, about ground effect. I think that a lot of interest can be found in military. You didn't mention that, because almost every vehicle is developed first for using in military, like helicopters or airplanes.
Yeah, but wing ground effect has already been developed in the military. Both the Russian and the German history has been heavily influenced by the military. And about 10 years ago, that changed a little bit because the Eastern-Western old conflict became a little bit different. The amount of money spent on new projects became a lot less, and the Ekranoplan program in Russia, for example, was one of the things that the budget got cut there, and it simply stopped. So it actually did start at the military, and currently I think that there may be some interesting government-related, as I said, customs, police, fishery inspection, that sort of thing, applications, and there may even be some military applications, but I don't think the military will now at this point initiate any further development. They may be users in the end, but I don't think they will initiate anything because they would have done it if they would have been interested.
Sasha Mavrovic from Zagreb. I'm wondering if now there is technology, because WIG can fly over sea, and salt water producing problems for engines and corrosion and that stuff. And I was wondering if today, are there any technology that would solve this problem for commercial use? Because our Croatian airlines, when flying over the Adriatic coast, they have really big problems with seawater in the air.
These are the same problems that have been experienced with, for example, search and rescue helicopters based on ships, or experienced by seaplanes. And they've been, for example, the engine problem has been solved by applying some sort of a coating on the rotor blade so that it doesn't corrode as quickly. And it also, especially the helicopters, they're being rinsed with clear water, with fresh water after every flight. So you have to take your precautions when you operate in salty water environments. But that's, I would say that's a technical issue which is easily to be solved. That's no big development problem, I think. There's choice of materials and that sort of thing.
Yep.
Excuse me, I have another one. Because there will be also a problem if you have a vehicle who is going like 200 kilometers per hour, and I wanted to put this vehicle between the islands. I will have to move all the small boats between those islands. It will be a problem
in practice, you'll see that when you operate the WIG craft, you'll be very fast, and all of the you'll have to regard all of the other boats as being static, as standing still in the water. So you will have to give priority to all of the other craft. So the other craft do not have to take account for you. Mm-hmm. So the WIG craft will need to maneuver around the other craft. The other craft do not need to maneuver around the WIG craft because they're simply too slow for that. Mm-hmm. So this is the main solution to this is good detectability and good maneuverability, and that's perhaps something that Mr. Fisher will say something more about in detail in his presentation.
So, well, I think that there is no more question. So there will be a coffee break, and we will be back at 10:30 for the last presentation.
Okay.
Thank you.
Very much.